have another example of sketching a plane curve using my analysis of intervals technique, since I'm given a set of parametric equations describing the curve. Well, looks to me like dx dt and dy dt are going to be the following. They factor as such. Sorry, it's the slopes in arithmetic. Is that going to give me just pulling out a t, I think? But of course, dy dx, the slopes of tangent lines, are the ratio of dy dt and to dx dt. So it looks to me like I have three critical numbers, 0, 1, and 4/3. Now those three critical numbers subdivide the real number line into 4 subintervals. Let's talk about those intervals. So the first t value was 0. The second t value is +1. Then it's 4/3. Then I'm beyond 4/3. So let's talk about dx dt and dy dt. Now for dx dt, looks to me like I'm always positive my t value is bigger than 1 and negative otherwise. Now, when it comes to dy dt, is quadratic with 2 zeros. It looks like when I'm on the outside of those zeros, I'm positive. When I'm inside, I'm negative. When I'm outside here, as well as here, I'm on the inside between those two. Now, I think what this is telling me about x and y is that x is decreasing. I misspoke, didn't I? I should say x is moving to the left. I mean, it is decreasing, but in terms of movement, in that direction, this direction, this direction. But y is moving upwards, then lower, or downwards, then upwards. And finally, what this tells us about the curve is I'm moving in this direction, then this one, then this one, and then that one. I don't know. I don't think it's going to work. I don't know if I'll be able to plot the points big enough. So how about if I condense this and just show what the curve is going to look like so I have more board space? I want to see all this. This is showing you work for using my analysis of intervals technique for sketching the graph of a curve described parametrically. But for the sake of room, let's go ahead and talk about the curve, which is moving in this direction, then that one, then that one, and then that one. Okay, I think I can do it now. Now let's talk about the points associated with those critical numbers. So one critical number was 0. But x and y are both 0 when t is equal to 0. So big dot, 0, 0 in black, but in blue, that was generated by allowing t to be equal to 0 itself. And in red, that was when dy dt is equal to 0, so my tangent line is horizontal. Now t is equal to, how about the other easy one? +1? Excuse me. The corresponding point is going to have coordinates -1, I guess also another -1. So at the ordered pair -1, -1, for which I generated a point when t was equal to, I think, +1, yes. Notice that was when dx dt was equal to 0, but that tells me my tangent line is vertical there. Little reminder. Now, if the remaining t-value is 4/3, oh no, some arithmetic, shoot. All right, I better slow down. The x-coordinate when t is equal to 4/3 is this. I said 4/3, yes. So can I just double check my arithmetic real quick? So 2 times that is yes. Okay, I like that. And then 24, I'm happy. And I think the corresponding y coordinate is yikes. All right, so -8/9, I'll slide it up. Corresponding y is going to be 4/3 cubed. Minus 2 times 16/9, that'd be 32/9. Excuse me. I think my arithmetic's correct. So at the order pair, -8/9, which is not quite as far to the left as -1, down to something less than -1. How about right here? That black point was generated with this t-value. And since I'm here, would you mind if I also found all my intercepts? And then I'll use my sign graph or direction graph to sketch the graph of the curve. Okay, so if I'm going to try to find the x-intercepts, those occur when y is equal to 0. But y is equal to 0 when t cubed minus 2t squared is equal to 0. That occurs here. Now remember, I'm trying to find x-intercepts. That is to say, when y is equal to 0. So it happens when t is equal to 0, but I've already generated that point. It also happens when t is equal to 2, but if t is equal to 2, obviously x is 0, but y is going to be 0 as well. And so when t is equal to 2, so looks to me like I passed to that point, 0, 0, also when t is equal to 2, so let me put that in blue, 0 and 2. And then lastly, for me to find x-intercepts, gosh, I think that's what I just did, didn't I? My goodness. To find x-intercepts, I set y equal to 0. I did. And so it looks like I crossed the x-axis only there, but I do it twice. To find the y-intercepts, I'll go ahead and force x to be equal to 0. And I get exactly the same t-values. So I got really lucky in this case. That is my x-intercept, that is my y-intercept, but it occurs at 2 different t-values. So finally putting things together to sketch this plane curve. So it looks to me as t increases up to 0, the curve is moving this direction. So it looks like I'm somewhere here in the 4th quadrant, but once I hit that point when t is equal to 0, my tangent line's horizontal. Now, as t changes from, I shouldn't say changes, as t ranges from 0 to 1, I move in the leftward downward direction until I hit the point where t is equal to 1, at which point my tangent line is vertical. Now, as t continues to increase from 1 to 4/3, my curve moves in the rightward downward direction until I hit the point where t is equal to that 4/3. But that's the point at which my tangent line is horizontal. I forgot to draw that in with my red pen. Horizontal. Okay, so let's hold on for just a second. Because when t is equal to 0 and t is equal to 2, I pass through this point. 0 is a 0 of both my numerator, I misbooked at 9. 0 as a number is a 0 only to the numerator dy dx, not its denominator. That's why the tangent line is horizontal. But notice if t is equal to positive 2, notice that my dy dx is neither 0 nor undefined. So I may pass this point again. My tangent line is neither vertical nor horizontal because dy dx is neither 0 or undefined. So as I increase beyond 4/3, my curve moves in the rightward upwardly direction, but I pass through that x and y intercept again. So I guess it behaves something like that, if it's not too sloppy.